So a lot of you for this question, I think most of you know what you are doing, but one confusion is, some of you have used the wrong dimensions. So if you, where is the plate? So you always need to think about it. So the plate is at here, right? And it has extension go inward to the paper. So so and so it's a, is it a triangular plate? No, this is a rectangle plate. It's a rectangle flat plate. If it's a flat plate, where should be its centroid line? We give it here, right? It should be at the middle of the plate. So the middle of your plate is here. So middle of the plate here. Then we find we were given this length is 60, and this length is 80, but we don't know this one. Because this is a right triangle, so you can calculate the L equals the square root of 60 square plus 80 square, which equals 100. Okay, then you know the middle of this one is here is 50. Here is 50 meters, and here is 50 meters. Okay, fantastic. And we say that the pressure from the surrounding liquid exert on the plate is only related to HCG. And HCG is the distance from the centroid to the free surface. And so here is HCG, right? So based on this, we can do our calculation that F equals gamma HCG multiplied by A. This one is just rho GH. So this becomes the pressure, then pressure multiplied by your area, you get the force. The water at rho 20-degree water, it equals 9790 kilograms per meters cube. You can also use 1000, it won't matters a lot. So and then this HCG, because this is at the middle, okay, so HCG should equals half of, this is, okay, the centroid is at the middle, right? Here, centroid at the middle. And so it's also the middle of this total height. So HCG should equals 40 meter. So how about your A? Your A, we have calculated this length. This length equals 100 meters, right? So your A should equals 100 multiplied by, and we said it is 30 meters wide into the paper. So it should equals 100 multiplied by 30. So this makes our F equals 9790. This is rho multiplied by 40. This is HCG multiplied by 30 multiplied by 100. And this is our A. So it equals 1.175 multiplied by 10 to the 9 newtons. After solving this, we need to take a look at YCP, right? YCP. So YCP should equals negative IXX sine theta over HCG multiplied by A. Sine theta. A lot of you, I think, a little bit confused. The theta was not given, but the sine theta is given. It equals, but the sine theta is given, right? Is given. You can either use 80 over 100. Your theta is here. You can use either 80 over 100, or because you can use your calculator to calculate this theta, which is 53.13 degree. So okay, so sine theta is, we will be able to know, and because we know L and B are known, so your Ixx can be calculated, and HCG we know and A we know, then it can be calculated. So the Ixx equals here equals BL to the third over 12, right? So it equals negative B equals 30, right? So 30 multiplied by L equals 100. We calculated before, right? We calculated here. So 100 multiplied to 100 to the third over 12 multiplied by 80 over 100. And then divided by HCG, we calculated here. We discussed it here. So that's 40 multiplied by A is here. 30 multiplied by 100. So it equals negative 16.67 meters, right? So that's YCP. So your Y, so the force is here. Let me use purple to join. So your F is here. So it's downward of your centroid here. Your centroid is here. So it's downward of the centroid. And to calculate M, so it equals to F multiplied by L. And if you want, you can also consider the weight of the dam itself. It will around the corner C. And if you think about it, if you put your hand there, you will find this force actually will act counterclockwise, which will reinforce the dam, right? Then this problem is solved. So this F we have calculated before, it's here, it's this F. And the L, what's the L? The L is this line, right? And we know this part is 50, and then we know yeah, this part is 50, but what we are looking is this part. Let me change the color. Let me use, it's this part. So if you connect it, you will find it's right between. If you connect it here, it's right between your centroid line here and the axial force. And what should be here? What should be, what is the size here? It should, this length should equals to your 80 multiplied by 80 over 100, which is 64, right? So it's this L equals to it's a little bit, let me see how I the Y, it equals this part, let me use green, it equals this part minus this part. Okay, great, minus this part, and only this small range is our L. and this part equals 64, and this part equals the length of this part minus your CG, so it equals 66.67 meters. So your L equals 66.67 minus 64. So it equals 2.67 meters. So your M, based on this calculation, is around 3.13 multiplied by 10^9 Newton multiplied by meter. And this force will reinforce the dam. So the fourth one is very interesting because I thought it's quite straightforward, but actually the description is a little bit confusing. So this 8-meter deep is 8 meters, and the length perpendicular to the paper, which is going inside into that direction, is 20 meters. So let's first have there are a lot of ways of dealing this, but what we want to show is we can first calculate the horizontal force Fx. So for Fx, its projection to here, what should be its projection? So if you consider about it, it's I will try my best to draw it. So it will look like this, and then it's go in. It's some shape like this, right? This is the window, and it's perpendicular. From this drawing, you will be able to see its projection actually is a plate, right? So Fx equals gamma multiplied by AV multiplied by YV. And YV is related to the centroid, right? So your YV should be here. This part, let me highlight it in red. So this part is YV. So let's reformat it as gamma multiplied by YV multiplied by AB. This part is rho GH actually. And then multiply by the area. Then you get the force, right? So the centroid of a plane is its center. So this part is 1.5 meters. So YV equals 1.5 meters plus 5 meters, which equals 6.5 meters. And A, it should equals, this side is 3 meter, and this side is 20 meter. So A should equals 3 multiplied by 20 equals 60 meters square. And gamma here should use water, right? So just use rho G equals 1,000 kilograms per meters cube multiplied by 9.8 meter per second. Meter per second square. So that's for gamma. So all numbers we know. So the final answer for this should be around 3,820 kilonewtons. Then we need to calculate Fy. For Fy, we said we always need to draw the diagram, right? A free body diagram. So the free body diagram connects the curved surface with free surface, and we need to calculate the weight here. And if you draw it, it will look like this. No. Look like this. Yes, correct. Yeah. And we can calculate the area here, highlight shaded area, then multiply by this length is 20, right? How to calculate this one? It equals this rectangle minus this quarter a quarter of a circle, right? So A here, A blue equals here is 3 and here is 8. It equals 8 multiplied by 3 minus a quarter, 1/4 multiplied by r equals to 3, right? For this circle. For this circle, r equals to 3. R equals to 3 multiplied by pi r square, right? So what you have here is your A, and then your V0 should equals to A blue multiply by the width or depth into the paper. It equals to A blue multiplied by 20. So you substitute the equation of A blue to here and then multiply by 20. What you get is 338.6 meters cubed. And then F vertical equals your rho multiplied by G multiplied by V0. This is the weight of your free body volume, which equals around 33110 kilonewtons. Then it's solved.